Hi, this is Annagoda IAP, working as assistant professor in Department of Electronics and Communication Engineering, Sri Venkateswara College of Engineering, Bangalore. And I'll be starting with a lecture series on network analysis. So, in my lecture series one, I'll be go explaining about source transformation. So, we know that network analysis is about uh, converting a complex circuits into a simple one. Okay, so through certain laws or theorems and also through certain reduction techniques. So one of the simplest way to transform a complicated network into a simple one is through source transformation. So the source transformation is, we know that we have two main sources, that is an voltage source and current source. So how to convert a voltage source into equivalent current source and how to convert an equivalent current source into a voltage source, that we will be discussing here. So first case, converting voltage source with series resistance R into an equivalent current source with the same resistance R1 I have considered. So I'm considering it as R1 here. So with across the terminals, whichever I considered, if I have considered across terminals A and B here, so I'll consider the same terminals A and B. And through Ohm's law, we can provide the relationship between, that is I is equal to V by R. So if I want to calculate I, so V by R1. So and the direction, we know that always current flows from a positive polarity, so we should point this arrow upwards. So this is how you can convert an voltage source into an equivalent current source. Similarly, the second case, how to convert an current source with the resistance, parallel resistance R1 across the terminals A and B into an equivalent voltage source V with the same resistance R across the terminals A and B. So V is equal to, through Ohm's law, V is equal to I into R. So this is a basic fundamental source transformation techniques, converting an voltage source with a series resistance into a current source with a parallel resistance, and similarly a current source with a parallel resistance into an equivalent voltage source with a series resistance R. So before starting with the problems on source transformation techniques, so we should understand, so we should understand, let's take for example, if two voltage sources of same polarity V1 with the series resistance R1, V2 with series resistance R2, if they are connected across the terminals, let's take for example A and B. So if I want to convert this, or if I want to replace these two voltage sources with a single voltage source, then as these two voltage sources are connected in series and these two voltage sources are of same polarity, so I can replace these two voltage sources with a single voltage source, that is V1 plus V2. And similarly, this R1 and R2 are connected in series resistances. So I can replace with equivalent resistance, which is given by R1 plus R2 across the same terminals A and B. This is case 1, where V1 and V2 are of same polarity. So if I consider case 2, if two voltage sources are of opposite polarity, V1 and V2, if they are connected across terminals A and B, then I can replace these two voltage sources with a single voltage source and to these two series resistance with a single equivalent resistance. But again, two cases will come in this particular condition, whether V1 is greater than V2 or V2 is greater than V1. In the first case where V1 is greater than V2, I can replace this two voltage source with a single voltage source, and if V1 is greater than V2, then take the polarities of V1, and equivalent voltage source will be V1 minus V2, and equivalent resistance value it will equal to R1 plus R2 across the terminals A and B, across the terminals A and B. That is for V1 greater than V2. Second case, if V2 greater than V1, if V2 is greater than V1, then I can replace these two voltage sources with a single voltage source. And now as V2 is greater than V1, go with the polarities of V2. So equivalent resistance will be R1 plus R2, and voltage source will be V2 minus V1 across the same terminals A and B. So this is what, if two voltage sources are connected in series, if they are of same polarity, then add those two voltage sources, that is V1 plus V2. If two voltage sources are of opposite polarity, then you are replacing a two voltage source with a single voltage source. Two cases will come, whether V1 is greater than V2 or V2 is greater than V1. Same case, we can go with same. If two current sources are connected in parallel, if two current sources are connected in parallel, how will you replace those two current sources with a single current source? Let's take, for example, I1 is in this direction, and with the parallel resistance R1, with the parallel resistance R1, and I2 in the same direction with parallel resistance R2. If they are connected across the terminals, let's say for example A and B, if I want to replace these two current sources with a single current source as they are in the same direction. So I can add these two current sources, that is given by I1 plus I2 with the same direction, and I can replace this R1 and R2 parallel resistances into an equivalent resistance, which is given by, if two resistances are connected in parallel, then I can replace those two resistances into a single equivalent resistance, that is R1 R2 divided by R1 plus R2 across same terminals. So this is a case 1, and if I go for case 2, if two current sources, if they are running in the opposite directions, let's take for example I1 is running in this direction with its parallel resistance R1, and if I2 is running in the opposite direction with a parallel resistance R2 across terminals, if I am taking A and B, then I can replace these two current sources, that is I1 and I2, into a single current source. And again, two cases will come here, whether if I1 is greater than I2. If I1 is greater than I2, then you consider the direction of I1, as I1 is dominant here, and which will be equal to I1 minus I2, and equivalent resistance will be R1 R2 by R1 plus R2 across same terminals B. AB across terminals A and B. And this is for I1 greater than I2. If I2 is greater than I1, then you are replacing, sorry, so if I2 is greater than I1, then consider the direction of I2, that is I2 minus I1, and equivalent resistance will be R1 R2 by R1 plus R2. So this is about, before starting the problems on source transformation, we should understand if two voltage sources are connected in series with the series resistances, then how will you convert those two voltage sources into a single voltage source? And if multiple current sources, if they are connected in parallel, how will you replace those multiple current sources with a single equivalent current source? Then only we can understand the problems on source transformation. So in my next lecture, I'll be explaining about, I'll be dealing with the problems on source transformation. Thank you.